Welcome back, my friends, to the show that never ends. Big Dog here working on section 2.3, multiplying and dividing real numbers. Let's get right into it. Alright, so let's go ahead and multiply some integers, and we're going to work with some rational numbers. So, first of all, we have 3 times 5. Some of these, again, should be real easy to get through. What's 3 times 5? Heck, that's 15. Okay, next one, we got negative 3 times negative 5. So I'm multiplying two negatives together. So remember back, what happens when I multiply two negatives? Well, a negative times a negative turns into a positive. That's going to give me positive 15. Next one, I have 3 times negative 5. So I got a positive number, positive 3 here, times a negative 5. What is that going to give me? That is negative 15. And lastly, just switch the signs here, negative 3 times 5. Well, hey, 5 is still positive, 3 is still negative, so that is still going to be negative 15. All right, so what should we know from these first couple problems? What we should have realized and maybe remembered is that when you have two numbers that are multiplied together with the same sign, I mean positive or negative, when they have the same, when they're both positive or both negative, what we find is that your result is that it's a positive number. If you have different signs, I'll just put diff there. Different signs means that they are going to result in a negative. Take a look at this last two examples. Again, that should be something you know up to this point. Okay, let's take a look at rational numbers. The first one, we have 7.4 times, remember parentheses, times negative 2.5. So if you're one of them dinguses that doesn't bring their calculator to class, which is a no-no, you might have to go the old school way of lining up the decimals and multiplying those two things together, right? You have to take the 5 times the 4 and the 7, then add a 0 and put the 2 and the 4, okay? Make sure you have a calculator. When you see decimals right away, I want you to be able to calculate it with your handy-dandy calculator. So what do we get as an answer? Punch this in, you get negative 18.5. Why negative? Well, hey, dingus, we just talked about that they have different signs, so your result is going to be negative. All right, the next one. We have multiplying a fraction, a rational number. 2/5, negative 2/5, times 3/4. What do we do here? Okay, so a lot of you might want to say this thing of cross-multiplying. That's a common response I hear. You're not going to cross multiply here, but instead when you multiply fractions, you're going to take the two numerators. Negative 2 and 3. Notice again how this negative I applied to that. So it's negative 2 times 3. Sorry about the writing there. That's going to give you negative 6. Then I'm going to multiply the two denominators together, 5 and 4. Notice I didn't apply the negative to the 5. All right? It's only applied to one of them, so I have 5 times 4, and that's going to give me 20. So I get negative 6 over 20. Only applied the negative to one of the numbers. And what do I get? Well, this one you're going to have to simplify. What number goes into both 6 and 20? Well, I know they're both even, so I know if I cancel out that by a 2, it's going to give me 3. Here's going to give me a 10. That's going to give me a result of 3/10. Okay, 3/10, I'm sorry. All right, so that's multiplying fraction, multiplying numerators and denominators. This next one, I have two rational numbers. I have negative 4/5 times 4. Well, you may look at 4. Well, 4 is not a fraction. Well, you silly nil, yes it is. Remember that all whole numbers can be expressed as a fraction over 1. So let me just rewrite this. You have negative 4/5. I'm going to apply that negative sign to just the numerator. Times 4 over 1. And now I'm going to apply the same method. I'm going to multiply the two numerators together. Negative 4 times 4. That's going to give me negative 16. Then 5 times 1 is going to give me 5. Can I simplify this fraction? No, I can't. So that right there is my answer, negative 16/5. Okay, so that's multiplying real numbers. And here's a couple more examples. First one, we have a mixed fraction. So anytime we want to do some work with a mixed fraction, let's turn it into an improper fraction. So again, the method is I'm going to multiply that, add that. So I have 4 times negative 1 is, did I just make that mistake? You bet I did. Remember, when that's negative, I was being a dingus for a second. When that's a negative number, this negative 1, we don't take care of the negative until the end. So I'm going to multiply 4 times 1 and then add 3. That's going to give me 7/4. And then I'm going to make that negative. Whoopsie daisies. I'm going to multiply that by negative 4/3. Now, what can I do here? Okay, sure, I can go ahead and multiply the two numerators and two denominators together, but notice how I have 4 in the denominator, 4 in the numerator. What happens when you have the same number in the numerator and denominator? Oh, well, think about it. What does 4 over 4 mean? Well, that is simply 1. So this is going to result in making a 1 in both the numerator and denominator. So what we can do here is not cross-multiply, but cross-simplify. What number goes into both 4 and 4? Well, it's 4. And if I take out a 4 from each, simplify those out, I get a 1. Once we have that simplified, now it's just simple multiplication. What we have to be careful for here is that notice that we have the same sign. We have a negative here, negative here. Again, I'm going to apply the negative to the numerators. So let me just rewrite this. This is going to be like negative 7 over 1 times negative 1 over 3. You don't have to rewrite that, but I just want to make sure you can see it. Then what I'm going to do is multiply the numerators, multiply the denominators together. That's going to give me negative 7 times negative 1. Same sign. That means it becomes positive 7. 1 times 3 is 3. I get 7 turds. Okay. Next one. Oh, I have these vertical bars. What the heck do these vertical bars represent? I totally forgot. I can't remember a dang thing. Oh, that's right. Absolute value symbols. So inside the absolute value, I have 3 times negative 8. So I'm going to evaluate what's inside the absolute value symbols first. That's going to give me negative 24. Take the absolute value of that. That means how far away is negative 24 from 0? It's 24 units away. So therefore I get 24. Next one, I have this sassy square root symbol. Again, that's something you should be able to do on your calculator and for some numbers in your head. So inside the square root, I have 3 times 12. So 3 times 12, what is that going to be? That's 36. What's the square root of 36? What's a number times itself that equals 36? And you should get 6. All right? So, tricky one here. I thought was the first one. You had the mixed fraction, cross-simplifying, things like that. So we're going to look for some of these rules within some future problems. All right, so one thing we talked about with addition and subtraction in our previous video is two properties called the commutative property and the associative property. So let's see if these apply to multiplication. So remember the commutative property says, in the simplest way I like to remember, is that order doesn't matter. If I take two numbers and multiply the others, A and B, and then I flip them and say B times A, do I get the same result? Let's try a problem. Let's say I take 2 times 6. Does that equal 6 times 2? Well, let's see. Well, 2 times 6, hey, that's 12. Does that equal 6 times 2, which is 12? You bet it does. So this property of multiplication does apply. Doesn't, in this case, if we're multiplying two numbers, the order in which I multiply them doesn't matter. Let's see if it applies for three numbers. This is, again, associative because we're grouping two things together. Think about what group you might associate yourself with. So let's say I take three numbers. So 2 times 3 times 5. Okay, let me rewrite that. That's not what I want to do here. But let's say I have 2 times 3 times 5. What I'm going to do is I'm going to group these first two together. And then let's take the same thing, 2 times 3 times 5, and let's group the second two together. Let's see what we get. Well, in this case, remember, you can only multiply or add or subtract or divide two things at once. So 2 times 3 here is going to give me 6, times 5, which I'm just carrying down because I haven't multiplied it yet, is going to give me 30. Let's see if that gets us the same thing on the other side. So here I'm going to start with the 3 times 5 first. That's going to give me 2 times 15. Again, carry the 2 down. 2 times 15 gives me 30. So, whoa, hey, it works. Good. So what I want you to get from this is that the commutative property and the associative property, just like addition, work for multiplication. Remember, it didn't work for subtraction. Keep that in mind. We'll come back to these a little bit later. All right, now let's get super sassy. Let's work on some division problems. Ooh. So the first one, we have 8 divided by 2. So you could do the long division way. I'm hoping by now you guys know how to divide. So 8 divided by 2 is going to give me 4. Okay, now let's divide by negative 2. 8 divided by negative 2. So what happens again if I divide by negative? That's going to give me negative 4. So positive 8, negative 2 gives me negative 4. Next one, I have negative 8 halves. You may look at this as a fraction. Well, fractions, my friends, if you haven't realized it already, is division. It's just a way of writing division. So what this really says is negative 8 divided by 2. I'm only keeping one of those negative. Remember, I always apply the negative to the numerator. So negative 8 divided by 2, that's also going to give me negative 4. Okay, so this one I have negative 8 divided by, or as a fraction over negative 2. Now notice what's different about this one. You have the negative sign in both the numerator and denominator. So what's going to happen here? Whoa, those are going to cancel out, and you're going to get positive 4. So what do we see again here? Well, remember, just like multiplication, when you have the same sign, whether both positive or both negative, you get positive answers. When you have opposite signs, like you saw in the second and third, you get negative answers. And another key thing I want you to get here, remember that fractions, when we view things as fraction, that really means you're dividing those two things out. All right, so let's go through a couple more sassy examples. The first one, 12.4 divided by negative 3.5. Oh, we got decimals, so what the heck are we going to use to evaluate this problem when we have some decimals? Oh, maybe you said your handy-dandy calculator. That's right. First of all, notice how I get positive 12, negative 3.5, so my result is going to be negative. Divide those out in a calculator, you get 3.5, 4, 2, 8, ... So you get what kind of number? Oh, that's right, an irrational number. Very good. Okay, good. All right, next one, I'm dividing fractions. So I have negative 2/9 divided by, notice this does not say addition, this is divided by 4/9. So I am dividing a fraction by a fraction. So how the heck do I do this? Interesting. I don't know. Oh, yeah, that's right. Here's what I'm going to do. I'm going to take negative 2/9, and instead of dividing by 4/9, I'm going to multiply by something called the reciprocal of this fraction. What is the reciprocal? The reciprocal, and let me write this down over here, the reciprocal is the flip-flop of the fraction. I'm going to take 4/9. Instead of dividing by 4/9, I'm going to multiply by 9/4. So I'm going to flip it and flop it a fraction. Okay? So, multiply by the reciprocal when you divide fractions out. Now what can I do? Well, now it just turns into a multiplication problem. I can cross simplify. 9 goes in with itself once, and holy strawberries, I have 2 and 4. Well, 2 goes in with itself once, and it also goes in with 4 2 times. So as a result, I'm left with negative 1 times 1, which is going to equal negative 1. And then I'm left with 1 times 2, which is going to equal 2. So my result is negative 1/2. So when you divide by fractions, folks, what you are going to do is multiply by the reciprocal instead. Okay, so let's take a look at the next one. Same idea. We have negative 3/5 divided by negative 2/3. Again, we're dividing fractions, so I'm going to take negative 3/5, and instead I'm going to multiply by the reciprocal, which is going to be 3/2, but the question is, what do we do with the negative? Okay? Well, the negative we are going to keep with it. The negative stays with. The reciprocal only means that we flip the fraction. We don't change the sign. Now, in this problem, can I go ahead and simplify? Does 5 go into 3 or any number go into 3 and 5? No. Same thing with 3 and 2. So this one I'm just going to multiply across, like we learned with fractions. Negative 3 times negative 3, well, hey, I got a negative times a negative. That's positive 9. 5 times 2, yeah, don't you know, hey, don't you know, that's a 10. So I get 9/10. Fantastic. Next one, I have 2 3/4. Oh my God, a mixed fraction. What should we do first? I'm going to do this before we start. Let's change this to an improper fraction. So 2 times 4, and then I'm going to, add the 3. It looks like a multiplication symbol. So 2 times 4 is 8, plus 3 would give me 11/4. And then it says divided by 4. Interesting. Well, look at divided by 4. Oh, I have a fraction times a whole number. I'm so confused on how to do this. Remember that 4, whole number, is a fraction over 1. So that's technically 4/1. So what can I do here? Anybody? 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 It is a fraction. So what I can do is take 11 over 4 and multiply by the reciprocal of 4 over 1, which is 1/4. So reciprocal, this thing comes in handy a lot. So let's go ahead and then just multiply the 11 times the 1. 4 times the 4, I just multiply because I can't simplify. 11 times 1 is 11. 4 times 4 is 16. I get 11 over 16. Fantastisch. This is so fantastisch. Okay, next one. I have the absolute value of negative 21 over 7. Okay, remember the absolute value bars, that stays. I'm going to look at inside. Negative 21 divided by 7. 21 divided by 7 is 3. Negative divided by a positive, that's going to give you negative 3. Okay, how far away is negative 3 from 0? It is 3 units away, so I get positive 3. Next one, I have a square root. You can punch this into the calculator. I don't want you to in this one. 27 divided by 3 is something we can do. That is going to be 9. Now, what's the square root of 9? What number times itself equals 9? Punch that into a calculator if you wish. Otherwise, you get 3. Okay, so here we go. Dividing numbers, including rational numbers. Keep in mind this thing about a reciprocal. All right, I want you right now to pause the video. Pause the video. I have 3 problems right here. I'm going to show you the solutions in a second, but I want you to divide these numbers out. We have some decimals, we have some rational numbers, and one including an absolute value symbol. So pause, 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 pause. All right, let's take a look at what you got. Here are the solutions. So the first one, should punch this into your handy-dandy calculator. First thing is I see a negative times a negative. No, it's going to be a positive. 20.3 times 14.8, you get 1.37. And then it goes on and on and on. It's an irrational number. Next one, I have 5/4 divided by negative 5/6. So what I did, dividing by a fraction, I multiplied instead. Multiplication here, multiplied by the reciprocal of 5 over 6, which is 6 over 5, and kept it negative because the reciprocal does not change the sign. Then this one you're able to simplify. I have 5 on top, 5 on the bottom, so 5 goes into both those numbers one time. Then I have 4 and 6. I can simplify there to 2 and 3. So what I'm multiplying by is 1 times negative. Don't forget about the negative when you simplify. Times negative 3 gives me negative 3. 2 times 1 gives me 2. I get negative 3/2. Next one, we looked at an example here when you're dividing by a fraction by a whole number. So a rational number divided by a whole number. Again, the whole number is a rational number of 3 over 1. So what I did is just rewrote this as the absolute value, don't forget about those, of negative 4/7 times 1 over 3. Multiplied here the tops to get negative 4, bottoms to get 21. Then I took the absolute value, which again makes that positive. So hopefully you did those well. All right, let's take a look. Now we talked about the commutative and associative properties for multiplication. Let's test it out for division. Okay, so here's an example. Again, to show you this, you have to show an example. So commutative property I'll do over here. So this is saying if I take two numbers, say 8 divided by 4, does that equal the opposite of that, which is 4 divided by 8? Does order make a difference when I divide? Well, what's 8 divided by 4? Well, 8 divided by 4 is simply 2. That's easy. But what's 4 divided by 8? Now, a lot of you will make this mistake. You might say 4 divided by 8 is 2, but 4 divided by 8 is not 2. 4 divided by 8 is 1/2, or 0.5, right? Think about division as a fraction, 4 over 8, that's going to give you 1/2. So are 2 and 1/2 equal to each other? No, they are not. So does this commutative property work for division? No, it does not. Let's go and look at the associative property. So let's take, again, 8 divided by 4 divided by 2. And let's see, does that equal 8 divided by 4 divided by 2? Now notice I'm not changing the order here in which I'm doing it, but I'm grouping these differently. Would it make a difference if I do that versus grouping those two first? So let's take a look. The first one, 8 divided by 4. Well, that's 2. Divide that by 2, your result, and you're going to get 1. Let's see what we get on the other side. This one I'm going to start with 4 divided by 2 first. What's 4 divided by 2? Well, that's 2. So now I'm going to have 8 divided by 2. What's 8 divided by 2? That's 4. Do those equal to each other? Absolutely not. So does the associative property work for division? Absolutely not. Okay, so big thing here, the commutative and associative property worked only for multiplication and addition, but not for subtraction and division. Ooh, that sounded like a Dr. Seuss rhyme right here. Didn't work for those two, but worked for multiplication and addition. So remember, when you multiply and add, order doesn't matter. All right, our last couple examples here, just some skills we're going to need for our next unit. So it kind of applies to division, so we're going to take a look at these now. So I have 8x minus 12. Yeah, I have the variable in there, but let's just worry about the numbers and keep the variable attached to this term. And I'm dividing this entire thing by 4. So what does this mean? 8x minus 12, all that divided by 4. Notice how we're dividing things. That's why we're talking about this now. Well, here's what we're going to do. This is kind of the opposite of what you would want to do at times, but this is a helpful little tool to have. Is that if I'm dividing 8x minus 12 divided by 4, what this really means is I'm taking my 8x and I'm dividing that by 4, and I'm also taking the minus 12 and dividing that by 4. So when you see something written like this, it means you're taking each term in this expression on the top in the numerator and you're dividing it by 4. Well, what does that allow me to do? Well, if you take a look at this first one, 8 divided by 4, well, what is that? 8 divided by 4 is 2. So this top term really becomes 2x. Minus, well, 12 divided by 4, that's 3. So I get, as a result, 2x minus 3. This is a helpful tool to have because when we look at expressions like this, it might help to simplify it down into this, which looks a lot neater. All right, let's try this next one. This next one, I have 2x plus 9, so we can, again, split this up. Take the 2x and the 3, and the 3 and the... Oh, it looks like a hard hunk count. So I get 2x over 3 plus 9 over 3. So I'm going to divide each term by 3. Now what I like to do here is notice how when I have this one, 2 divided by 3, I can't divide that. So there's no sense in doing that. I'm just going to leave it as a fraction. When I rewrite this, however, I'm going to write 2/3 x. I'm going to separate the number and the variable. I'm not going to say 2x divided by 3, but I can say 2/3 times x. Okay? Next one, I have 9 divided by 3. Well, that's easy. That's 3. Okay? So I can simplify that out to this. Now, the reason why I'm doing 2/3 x and not 2x over 3 is because really, if you think about it, and this is kind of tricky, x is really x over 1. So when I say 2/3 times x, I'm really saying times x over 1, because anything divided by 1 is itself. Well, 2/3 times x over 1, if I apply my rule of multiplying fractions, that's going to give me 2x over 3. So these two things really mean the same thing. I just like and prefer you to write it like this, so we separate the number and the variable. All right, last example, we have 8 plus x divided by 6, so let's go through the same thing. I'm going to divide 8 and 6, 6 and x, so I have 8 over 6 plus x over 6. All right, so 8 over 6, that's something we can simplify. Both those are even, so I can divide by 2 and say 4 and 3. So this is going to give me 4/3 plus, well, remember, just like the last example, I have a number in x, but I want to separate these two. Well, what the heck is the number in front of x? When I say just x, is there a number in front? Somebody might say 0, but in fact, the number in front of x is a 1. So when I separate this out, I can say 1 over 6x. Okay, so if you just have the variable by itself, the number in front is 1. Again, this is a skill we're going to need for some future problems that we're going to see. All right, kids, I hope you enjoyed the video. Good luck on the practice problems. If you have any questions, make sure you ask. All right, guys? We'll see you later. Catch you on the flip side.